is our feedback element. Again, after the G1, G2 is given, G3, again G3 a summing point is given, and then G6 and CS is indicate our output signal. So, using block diagram reduction techniques, we have to find the transfer function of the system. So, first of all, what is the transfer function of the system? So, it is the ratio of Laplace of output signal upon Laplace of the input signal. So, first of all, which rule is applicable for this particular example? So, here you can see that always start with the input signal. After the input signal, a first summing point is given. So, there is no rule applicable. After the second summing point, G1 and H1 will be in the feedback part. So, we can use rule number 3, elimination of the feedback loop. Again, after this feedback loop, a G2 gain is given, and after that, G3, G5 and G4 is in the parallel loop. So, we can also apply a rule number 2, blocks in parallel connection. So, for this, in this example, we cannot apply a rule number 1 directly because there is no block in the series connection. So, rule number 1 cannot be used as there is no immediate series block. So, the second option is we can use rule number 2, block in parallel connection. Which block in parallel connection? It is G4, G3 and G5. And here you can see that the sign of the G3, G4 and G5 is positive. So we can add this block and the final output is red. Here you can see that the yellow color indicates we can apply a rule number 2, block in parallel connection. Here sign is positive. So we can add this block and we can get this type of block diagram reduction. Okay, G3 plus G4 plus G5. Now here you can see that G2 is directly connected with this block. So simply we can apply a rule number 1, block in series connection. And what is the rule number 1? Whenever more than one block is connected in series connection, we can multiply this block. So the final output is G2 into G3 plus G4 plus G5. So the final block diagram is G2 into in bracket G3 plus G4 plus G5. Now, as we can discuss earlier, G1 and H1 is connected a feedback loop. So we can apply a rule number 3, elimination of the feedback loop. Now, what is the rule number 3? The output of the rule number 3 is we can put a forward part G1 upon 1. We can see the sign of the feedback loop. Here the minus sign is given. So the equation will become G1 upon 1 plus G1 into feedback part gain, and it is the H1. So the final output will become G1 upon 1 plus G1 H1, and again the second block is G2 in bracket G3 plus G4 plus G5. Now again the two blocks are connected in this series connection. So simply we can apply a rule number 1, block in series connection. So we can apply these two blocks in the multiplication and we can get this type of block G1, G2 in bracket G3 plus G4 plus G5 upon 1 plus G1 H1. Okay, now here you can see that H2 is our feedback element and G1, G2 in bracket G3, G4, G5 upon 1 plus G1 H1 is our forward element. So easily we can apply which rule? We can apply rule number 3, elimination of feedback loop. Now one important thing is that whenever we apply the rule number 3 and the rule number 2, the summing point is cancelled out from this block diagram. So we can apply rule number 3 and the simplification is like that. G1, G2 in bracket G3 plus G4 plus G5 upon 1 plus G1 H1 plus G1 G2 H2 in bracket G3 plus G4 plus G5. Now you can easily identify that G6 is directly connected this block. So which rule is applicable? We can apply rule number 1, block in series connection. So we can simply multiply G6 block with this block and we can get this type of block G1, G2, G6 in bracket G3 plus G4 plus G5 upon 1 plus G1 H1 plus G1, G2 H2 in bracket G3 plus G4 plus G5. Okay, now we have to find the transfer function of the system. So the final equation of the transfer function is C of S, that means the Laplace of output, upon R of S, that means the Laplace of input, is equal to G1, G2, G6 in bracket G3 plus G4 plus G5 upon 1 plus G1 H1 plus G1 G2 H2 in bracket G3 plus G4 plus G5. So this is the simplified output of this block diagram reduction. Here G1, G2, G3 is our process, is our system, and the feedback element is our transducer or is our system sensor. Okay, now let's take the second example. Also in the second example you can see that again R of S is our input or the reference input and the C of S is our output signal. Now between the input and output number of blocks is given. So first of all we can identify which rule is applicable first for this particular example. So after the input a summing point is given, but the first summing point again the second summing point is given. So there is a no rule applicable. Okay, after the second summing point G1 and G2 is given. Now G1, G2 is the forward gain of the system. Now G1, G2 is directly connected in series with the system. So we can apply a block in series connection and it is the rule number 1, block diagram reduction. So we can apply rule number 1, block in series connection. So we can simply multiply the gain G1 and G2 and we can get G1, G2. Now the next is G3 and G4 is connected in parallel connection. Now how we can identify that it is the parallel connection or the feedback loop? So if all the arrow is coming to the summing point, means all the arrow is incoming to the summing point, that is the parallel of the system. If one arrow is outgoing of the summing point, it is indicate it is the feedback loop of the system. So here for G3 and G4 block we can apply a rule number 2, block in parallel connection. So first of all we can check the sign of the summing point. Here the sign of the G3 is plus and the G4 again plus. So we can simply add this block and we can get this type of block G3 plus G4. Now the next step is here you can see that G1, G2 and H1 is connected in the feedback loop. Now how we can identify that it is the feedback loop? So here you can see that one arrow is in the output position and one arrow in the incoming position in the summing point. So it is the feedback loop, and whenever the two block is connected in the feedback loop, we can always apply the rule number 2, elimination of the feedback final equation will become G1 G2 upon 1 plus G1 G2 H1. Okay. Now here you can see that G3 plus G4 is directly connected to this block, and whenever the two block is connected directly with that, we can apply the rule number 1, block in series connection. So we can multiply this block and reduce this block, and the final answer is this G1 G2 in bracket G3 plus G4 upon 1 plus G1 G2 H1. Here now the next is H2 is connected with the feedback loop in this block. Okay, so we can simply apply the rule number 3, elimination of the feedback loop. Whenever we elimination the feedback loop, the summing point is cancelled out and we can reduce these two blocks into one block. So final answer will become the forward part. Here the forward part is G1 G2 in bracket G3 plus G4 upon 1 plus G1 G2 H1 upon 1. Here the feedback signal sign is positive, so we can write that 1 minus forward part into feedback part gain. So we can get G1 G2 in bracket G3 plus G4 upon 1 plus G1 G2 H1 minus G1 G2 G3 H2 minus G1 G2 G4 H2. Okay, now the final step is we have to find the transfer function of the system. So the equation will become C of S upon R of S is equal to G1 G2 in bracket G3 plus G4 upon 1 plus G1 G2 H1 minus G1 G2 G3 H2 minus G1 G2 G4 H2. So this is the final answer of the example number 2. Okay. Now next example number 3. Again here the input signal is given and the output signal is given. Between the input and output number of blocks is given. Using the block diagram reduction techniques method, we can reduce the block and we can find the transfer function of the system. Okay, so first of all, start with the input signal. After the input signal, a summing point is given. After the summing point, a takeoff point is given. Okay, after this takeoff point, a G1 block is given. But after the G1 block, again summing point is given. So we cannot apply any rule of the block diagram reduction. So let's move on. After the second summing point, a G2 block is given and H1 feedback loop is given. So we can apply rule number 3, block in feedback loop. So easily we can apply rule number 3, elimination of the feedback loop. So the final answer is G2 is our forward path, H1 is our feedback path, and the sign of the feedback signal is negative. So we can simplify this equation using elimination of the feedback loop. So we can get G2 upon 1, sign is negative, so 1 plus forward path G2 into feedback path H1. So the simplified version is like this, G2 upon 1 plus G2 H1. Now here you can see that G1 and G3 is directly connected to this block. So we can easily apply a rule number 1, block in series connection. Here 3 blocks connected in the series connection. So we can simply multiply to this block gain and we can get this type of block G1, G2, G3 upon 1 plus G2 H1. Okay. Now here you can see that G5 is connected to this block. Now which rule is applicable? So here you can see that summing point, the first forward path is G2, G3, G4, G2, G3, G1, G2, G3 upon G2 H1, and the second gain is G5, and the both arrow are incoming the summing point. So we cannot apply the rule number 3, block in elimination of the feedback loop. For this particular, we can apply a rule number 2, block in parallel connection. And here the sign of these two block is positive. So simply we can add this block in and we can get this type of block G5 plus G1, G2, G3 upon 1 plus G2, H1. Now here you can see that G4 is directly connected with this block. So simply we can apply a rule number 1, block in series connection. Okay, so simply G4 is multiplied with this block and we can get this type of answer. G4 in bracket G5 plus G1, G2, G3, 1 plus G2, H1. Now H2 is our feedback loop, okay, because the arrow sign is opposite, okay. So compulsory we can apply the rule number 3, elimination of the feedback loop. So first of all we can check the sign of the feedback signal. Here the sign of the feedback signal is negative, so we can get this type of answer G4 G5 plus G2 G4 G5 H1 plus G1 G2 G3 G4 upon 1 plus G2 H1 plus G4 G5 H2 plus G2 G4 G5 H1 H2 plus G1 G2 G3 G4 H2. This is the simplified version of this block. Now the last step is we have to find the transfer function of the system. So the transfer function is the nothing but the